even close. If you step on it, it's not going to go. I'll keep a distance from you so you don't have to worry about it that way. With it being tight, it's rolling. Maybe a little bit sticky. So you may want to think about what you do to make sure if that's a problem for you. All different heights. On the bus. Right. You're going to want to move that hand. It's going to come out that hand.
No, I know. We're trying to make sure this is
gonna hit me?
Oh, let me know when you want to fire. When you want to fire. 2. You know, you're going to go from this tape, regional.
How are we counting down?
Which tape are you going to? Which tape are you going to? This one? Yeah. Not this one? This one. This one.
No, the bigger one. No, the bigger one.
Probably the back of it. Probably far back. Well, you guys don't know, I guess. So, whenever you're ready. Move this to where it needs to move to, then this just switches back and then fires. So switch back and fires. So it will go pretty good in there. You want it all the way in there. Something like that would be ideal. You don't want it to be like that. I'll count it off because I'll be using this for both of these.
So what are you going?
So, 3, 2, 1.
On one.
One.
So it's 3, 2, 1.
3, 2, 1.
Go ready?
When you're ready.
3, 2, 1.
We found the equation for the ball being dropped by taping meter sticks to the wall and marking every 10 centimeters. When we took a couple of videos of the ball being dropped with the bottom of the ball at the very top of the meter stick. Then we analyzed the videos using Movie Maker to find out how long it took the ball to reach the markers on the meter stick. We then plugged our numbers into the graphing calculator and found the equation.
We found the equation for the CO2 power by placing meter sticks in the hallway and marking off every meter up to 8. plugged our numbers into the graphing calculator and found the. We launched our car from 12.4 meters. Our stunt was not successful. We were too far away from the job when we launched our car.
We failed because of human errors when analyzing our videos, and we all weren't here on the same days, which made parts of the challenge more difficult.
What we would change is how we analyze our videos of both the tennis ball and the CO2 car. We would also try it all easier so we could notice more mistakes and complete the whole challenge as a team to come up with more reliable and correct information.
That there's only a couple things. That is not the final equation of your car, and that's also not the final equation of your ball either. I'm pretty certain of that. Do you know what the final equation of both of them are? That describe the equation of the ball being dropped. How far is it being dropped from? That needs to be altering your equation of your ball, correct? Same thing with your car. The car's equation is altered based off of where it started. So make sure that you take that and keep that in mind. It does affect it. However, I appreciate the way that you address the fact of your communication. In engineering, it's the same thing. You may not have all of your coworkers there at the same time, so communication becomes crucial. There actually could be one person from America, one person from England, and one person from Australia, all working on the same project. And if you don't leave good detailed notes of exactly where you are and exactly where you came from, that next person that's going to pick up on that project will have to start all over again. Which is kind of what happened with this group, because one person would be absent, they did the work, and the next day the other two would be absent, and then they're trying to play catch up to figure out where they were. So there's probably a good day and a half to 2 days lost in communication of redoing work. I think your whole thing could have been done extremely well if communication would have been hit a little better. Write the equation, final equation of your car up on the board in the top right underneath there, please. That is probably in that paper. Make sure you grab it and write it, because it's not that one. I need the next group to start going up there and preparing everything.
I'm sorry.
Don't apologize to me. I mean, it's.
Just start, please.
Okay, basically to find the equation for the ball, we dropped the ball in front of some meter sticks and we recorded it to figure out how far the ball fell every time, like in what time. So that helped us find the acceleration of the ball, and we used the information that we found, where like the distance that the ball had moved at the time, to make a graph, and then we plugged that into a graphing calculator, found the equation, and do you want to do this part? Oh wait, the equation for our ball was y equals negative 426.5x squared plus 57.8x plus 420.37.
In order to find the equation for the car, we took 5 meter sticks and lined them up down the hallway and marked off for every 10 centimeters. Then we filmed that, and then we put it in the movie maker to look through frame by frame to see where the ball was at, and where the car was at each kind of move. We were not able to get clear, accurate data due to the camera. Its quality was not the best. We should have used a better camera. We were able to get it close enough of what the equation could be. We took that and put it in the graphing calculator in order to find out what the equation would actually be.
Let's see. Okay, so our stunt wasn't successful, and well, we made our car 1,369 centimeters away from the ball drop region, badly. And we think it's probably, it was pretty bad.
Get away from the drop zone.
And it was probably just because our videos might not have been the best quality, so some of our measurements were probably off. And our car was obviously way too far away from the ball when it hit the ground. So,
If we could do this again, we would get more precise measurements. We would also like to make the distance between the car and the ball drop region shorter.
Okay, so how would you get more precise measurements?
In order to get the more precise measurements, we would have had a better quality camera to film it, so we were able to pinpoint where the car and the ball location were at that exact moment. Because it was kind of blurry, it was hard to keep up with the car, and didn't see it too, how quickly it moved. So it was blurred out, and we weren't able to get precise measurements.
What was the range that you tried to videotape of?
5 meters.
Your car was 5 meters, was the range you were videotaping?
Yes.
And you tried to videotape every 10 centimeters? But then you marked off every 10 centimeters?
every 20
Just
cents.
20?
20.
Was it a still camera that you were using? Were you sitting there watching it, or were you trying to follow it? Did you try to follow it, or did you
We
sit?
did two
sit-
videos. One was
When we
following.
took the video, we would sit still and watch it where it would hit.
We just sit there and
And
just
then-
turn it.
He's talking about how you
That's
held the
how you
camera.
capture the
we
video.
I just said held it still.
So if you just held it still, then that's one thing. I was just asking to see if you were holding it still or if you were trying to
I thought you
capture.
were talking about like when we tracked the measurements.
We did two different videos, so one was turning and one was still. One was a little bit turning.
Was your whole group there when you shot the video?
No.
I haven't taken a different
Pretty
video.
sure Tristan wasn't here. Tristan over there.
Okay, all right. Make sure you were. Oh, never mind. You can't write the equation in your car. Go. I think you're missing something on the car equation. Two things actually.
We dropped the ball from 200 centimeters and recorded it. To get our data, we analyzed the video, and then we found the acceleration for the ball. Then we released the CO2 card and recorded it. And we analyzed that data and gathered the data.
We shot our car from 5.3 meters away from the drop zone. Our launch was a success because we were able to get the car under the ball without it hitting or dropping in front of it, and we were about a meter away from the drop zone. And the ball hit.
Our reasons for our success was that we were able to get accurate data from the ball drop in the videos for the CO2 car. And if we were to do this again, we would have better quality of the videos, like more than 2 videos, and better communication between everyone in the group.
Yeah, we changed, for the ball equation, we changed the C value to get, to the height of how far we were dropping the ball, so that it would be accurate.
Now look at the one below that. Did you do that to that one?
When we we plugged this into the calculator, and when we got X, it was like 0.8133, and then we took and we plugged the X value into the car equation, and we didn't have this was there. We made that 0, because we were shooting from 0. Yeah, so that would be 0.
Well, maybe it started out as 0.
Yeah.
But where was it when you actually shot the car?
Was it 5.35?
How's that going to affect your equation? All right, you ready? I'm going to fire off questions.
Yeah.
0.81. What did 0.81 stand for? You said X equals 0.81. What does that mean in this situation? What does it mean in real life in this situation?
It was how long it would take the ball to drop the 420 centimeters.
All right, ball needs to, it drops and,
From the starting point, when we shot the car, and dropped the ball at the same time, it would take the ball 0.81 seconds to hit the ground.
all right, so why'd you plug that into the car equation?
To see how far away we would need to make the car.
All right, and then is your car and your ball, is it measured in feet, centimeters, inches, meters?
Centimeters.
Thank you. That's the fix I was looking for. All right, write the equation of your car up on the board, please. Shifts. I know in my job in the Air Force, it worked on a shift. I had to document things 3 times if I did something. If I went out there and I screwed a panel onto the jet, I would write it in the forms on the jet. Then I would go in and type it into the computer. Then I would go into my office forms and I would write on my office forms. They were tracked 3 different places. Because noticing that communication is key. If one person does something and no one else knows that they did it, one, it's either going to be done again, or it's going to be totally forgotten about and can end up screwing everything up. And F-16s are worth millions of dollars. So something like that that's forgotten, a jet goes down, the first thing they do is go to the forums to see what everything was done. And then they go to the office forums to see what everything that was typed up or written out. If something was typed up and written out and done on that jet that wasn't put on the jet forms, that person's held liable. So communication is big. In this world, it's huge. All right? And if you're going to go into engineering, you need to make sure you're focused on that. If you're not going to go into engineering, you want to open up your own business, you need to focus on that, especially with your employees as well. Now, looking at the equation of this, if you look at your equation of the ball as well, the ball drop actually should have followed somewhere like this in meters. Centimeters would have been something like this. Feet, did anybody do it in feet in here? Nobody did it in feet today. So if you did meters or centimeters, it should have somewhat close to this. Your B value should have been somewhat close to 0. The only way it would have altered is because of the air coefficient, friction from the ball actually dropping against the air. However, this is a free-falling equation. 4.9 x squared and 490 x squared that's in centimeters and meters of a ball dropping in free fall. assuming that there is no air drag and air resistance. So if yours was close to this, then your ball equation was pretty close. I would love to give you the equation of your cars and what they should have been, but none of your cars fire the same. That has to do with how you made your car. Some of you set it up to where your car had a little bit of wobble. Well, that would affect it. The way that your screws were placed on your car and how far they were from front to back kept it more on a straight line. If you screwed it very close to the car, that string was rubbing up against the car and causing friction. None of your cars were the same equation. As you can see up here, none of them were the same. These two, actually, these two aren't even relatively close because yours is in centimeters, is this correct? And this is in centimeters, and this is in meters, right? So this is like 300 meters, 700 meters, 8.9 meters, negative 8.9 meters. So you can see none of the equations of the cars are the same. And I've talked to numerous people before this whole project started, 2 physics professors at UC, an engineer with a PhD, a science teacher that has gone through and now writes tests for future science people. All right? None of them gave me the same answer as to what to expect for this equation. Because nobody knows 100%. One physics teacher said, the college physics level, they said that you can probably expect it to be somewhat logarithmic because a rocket could be logarithmic. Well, I was like, shoot, well, that's going to screw me up pretty bad. That's an equation you haven't studied yet. Then another one said, I think it could approximate linear on a short distance. And another one said, well, it could approximate quadratic on a short distance. Nobody knew 100%. So the thing that was happiest for me when I saw you do this was your R-squared values. Because what did you notice when you saw your R-squared values? A lot of you were getting what? What did your group get? For your car? 0.995 for it being a what? Quadratic. What did your group get for R-squared? Do you remember? None of the forms you don't remember? Did your group remember?
We got 0.943 quadratic.
And yours?
I think we got like 0.94-ish.
So that's saying above 90%. And actually, in the other class, there was a few 0.99s as well. That means it approximated, really close to a quadratic at that point in time. That 0.99 probably explains why your group was successful. The video you took seemed to be pretty good. Some other groups were unsuccessful just because of timing, I believe. There's a human factor that comes into play here. You dropping the ball. You releasing the CO2. So just because you weren't successful as far as the car actually going and dropping the ball, doesn't mean you didn't find the equations the best that you could have with the video that you took. The glitches in the videos that you noticed. I'm glad you brought those up. Better video quality will equate to better equations. All right. So with the rest of the class, you're going to rate everyone in your group. So what I want you to do is kind of spread away from your group members. I don't want to have any of this pressure where somebody's looking over your shoulder and see what they rated you. All right? Never good. I always had to double check, triple check, quadruple check. I always knew that I had to make sure I went over his work or had somebody else go over it because it was never going to be good. All right, so that's how you're going to rate the person. Make sure you do score, comma, score, comma, score, comma, score, and put a name next to it for everyone in your group. And then you're going to turn it in.
Wait,